So the learning target for this lesson is using t-tables to graph and recognize the differences among linear and exponential equations. We've done a lot with linear, so this is really about exponential equations, how to graph them, and the differences between the two. So a quick review on linear, so you can tell the difference between them. So start with $50 and add 5 per week for 10 weeks. So we start with, at week 0, we have $50, and every week we are adding an extra $10. And so just take a second to do that. And then I want you to pause the video and see if you can make the graph for it and write the equation. And of course, I've already told you the type of relationship is linear. So pause, see if you can finish the table, write the graph, make the graph, and write the equation. Okay, so hopefully you paused and you have an idea of what your graph looks like and what your equation looks like. The first thing I notice when I'm making my graph is that I have to go all the way up to 100. So I finished my table, so hopefully your table matches. We started at 50 and we went up 5 for each week. Okay, and then I started my graph by labeling my axes and numbering this. I didn't number this yet just because I wanted to show you. I have to get up to 100, so I'm going to count how many there are and see what I could number by to get to 100. So if I count by 5s, that works perfectly, but as you know, I tend to number every other one. So 5, 10, 15, 20, 25, 30, 35, 40, etc. So take a moment if you've not made the graph to do that. And to graph it, you are just plotting each ordered pair. So 0, 50 is an ordered pair. So 0, 50. And then for each week, we went up another $5. So at week 1, we were at 55. At week 2, 60. At week 3, 65, etc., etc. So we're just plotting the points and connecting. And the reason it is a linear relationship is because it makes a straight line. So the characteristics of a linear relationship, it makes a straight line on a graph, and it goes up at that constant rate. It went up 5 for every one. That is what makes it linear. It's going up at a constant rate. The equation, remember an equation of a linear relationship fits that y equals mx plus b. So hopefully you wrote y equals our rate. We are going up 5 for every one, and we started at 50. So my slope was 5, and my y-intercept was 50. So today is really about figuring out the differences between linear and exponential. And in exponential, we're going to be talking about exponential equations quite a bit in the next couple lessons, but right now notice that our independent variable is in the exponent. And so when you make a graph of something like this, our independent variable is in our exponent. So we're going to start just by making the x's. So I'm going to make it just like I did for the last one by starting to just number. And then you need to plug in the x for the exponent. So 2 to the 0 power, you've actually done this in the beginning of this unit. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8, etc., etc. So please pause. Take a moment to finish the table. Think about these two questions. Well, first do the graph and then think, what is different about this graph and what pattern do you notice on the table? Because you're going to have to be able to look at a table and a graph and decide what type of relationship it is. So see what you can see. What is different about this graph and the table than what we just did? So pause now and finish up. All right, so before we graph, let's just look at that table. Are we going up at a constant rate? Here we went up 1, and then we went up by 2, and then we went up by 4, and then we went up by 8. So we are not going up at a constant rate. So can you find a different way that shows the pattern? What is the pattern on the table? We talked about this when we talked about zero and negative exponents. Really what you're doing every time is multiplying by a power of 2. Where do you see that 2 in the equation? So be thinking about that. And then when you graph, it is really difficult with this type of relationship to show exact. So I know at 0 I was at 1. Well, I numbered my graph by 25s. So I know I'm going to be very, very, very close down here, but it's going to be an approximation. So it's going to be very close. And at 1 I was at 2, so it goes up hardly at all. And at 2 I was at 4. And so at first it hardly seems like you're going anywhere at all. At 4 I was at 16, so remember this line right here is 25, so I'm almost halfway. Oops, at 4. And at 5, now I've went up to 32, so now I'm above the line, almost halfway to 50. And then at 6, I was at 64, so 50, 75, so not to 75. And at 7, I was at 128, so way up here. And at 8, 256. This is supposed to be a 9. And at 9, I was at 512, which is way off the graph up here. So you can see it started out really slow and then curved up. That exponential curve. So your assignment today is, again, looking at tables, looking at graphs, and comparing them to linear relationships.